process the quantitative data A, B, C, D, 1, 2, 3, 4, 5, all these are quantitative, then it's much easier with the use of different tools. For example, you will need to deal with different kinds of pre-processing. You have to make sure that all these ID should be unique. This is not unique, perhaps it's because because we have the same respondent, same ID, but then they respond 2 times. They fill in 2 times. So this record is ambiguous. It's confusing. We're not sure which one is the correct one. In this case, shall you remove one of it or shall you remove both records? It depends on your context. Then we have to also make sure that all the format of your data should be consistent and standardized. If you have missing value or invalid value, for example, under gender, we only allow F and M, female and male. What will happen to A? A is an invalid value that you have to replace it with F or M. Now, how do you replace these invalid and missing values? Normally, we will replace it by using mean or average, or sometimes we replace it by maximum. What is the maximum value? What is the highest value? Say, for example, under the gender, we might have a population of 1,000 people. And out of this 1,000 people, we have only 20% of female, 80% are male. In this case, if you are replacing this invalid value by making use of max, M-A-X, max, then you are going to choose male instead of female. Likewise, in the missing value here, which city should you replace? Which city should you replace? We can also use the highest appearance of certain city, the max. Which one appear the most? Then we will replace it with that city name. For example, most of the participants come from Dublin or Paris, maybe. Then we will replace it with Paris. For misfilled value, for example, Italy should fall under country, not city. So in this case, you should replace this value or you should remove this record. How do you decide whether to remove or to maintain the record? Again, it depends on the context. And therefore, in your research, you have to let us know how you are going to deal with each of these missing values and present it in a flow chart like this. This is what you should present in your research report. How you deal with the missing value, how you deal with the variables with missing value or the cases. Variable and cases are different. Okay, variable and cases are different. Cases means this one. This row is a case. This row is a case. And this is another case. Or respond from one respondent, we call it as a case. Whereas a variable means the column. For misspellings, you will have to replace it with correct spelling, definitely. And then attribute dependency means this is depending on this one. If let's say teacher, student means you are not going to be the teacher. Oh, sorry, the student, sorry. This value will be depending on whether you are a teacher or not. If you are a teacher, then you will have number of students under your guidance. If you are not a teacher, for example, the 0 here means you should shouldn't have any student here. If you're not a teacher, you shouldn't have any student. So in this case, there is a 0 here, and you still have number of students, which is incorrect. Attribute dependency issue. All these cases, all these are under data pre-processing that you will have to deal with it. Now, according to one researchers from Cambodia, they are doing big data analytics. They share that for one big data set, they spend about 6 months. 6 months just to do data pre-processing to make sure that they have a correct data set in their analysis. Likewise, for your seniors, the data set that they have got from the ICPSR data set, they have 1,831 from DS8, and I spent 10 weeks to do data pre-processing for your information. For missing value, you can use a midpoint in the scale. Like for example, you have a 5 Likert scale, agree, strongly agree to strongly disagree. How do you replace the missing value? You can use mean, or you can use midpoint in the scale, which is 3, somewhat agree or neutral. You can also use mean value, or you can use random number, or you just remove this variable. If let's say the missing value is more than 30%. So that's why we have something like this. If you have a variable, if you have a variable with missing value more than 30% missing, then we will choose to remove it. Remove the variable. So you have to tell us how you deal with all this missing value. Do you replace it with mean, midpoint, random number, or remove the column directly? So the reader will know how to do the pre-processing, because they might want to use your way to also cleanse and transform your data. Okay, let's move on to the data analysis. We have different data analysis like t-test, ANOVA, correlation, regression, chi-square, one-way ANOVA, two-way ANOVA, under ANOVA. And all these can be categorized to investigate differences. We have t-test, ANOVA. To investigate relationship, we have done this, person correlation, whether there's any relationship between A and B, variable A and variable B. That is the most straightforward one. Regression, and then non-parametric, we have chi-square. So let's take a look at each one of this. Again, data analysis is used to test your hypothesis, to find out whether your result is significant or not, in order to reject your null hypothesis or to accept your alternative hypothesis. Let's refresh on the so-called hypothesis. Okay, hypothesis, we have null hypothesis and also alternative hypothesis. Alternative hypothesis is what you are doing now, and null hypothesis is the opposite. For example, we have hypothesis telling us that family economic correlates positively with academic performance. This is what you predicted to happen. This is what you predicted to happen. Null hypothesis, family economic does not correlate positively with academic performance. It's the other way of alternative hypothesis. And therefore, in your assignment, please don't give me null hypothesis. Don't give me null hypothesis. I repeat, give me one null hypothesis. I minus 1 mark in your assignment. I repeat, assignment, no null hypothesis. Don't give me null hypothesis. If I see null hypothesis in your assignment, one null hypothesis minus 1 mark. End of the day, I don't have to mark your assignment because you have 30 or 40 hypotheses, right? Then I minus 40 marks directly, right? No need to mark your assignment anymore. Why? Because you have so many alternative hypotheses. Null hypothesis is just the other way. So it's like useless to do this. But then you will need to know what does it mean by null hypothesis. And therefore, when you accept means when your result proves that this is correct, this is okay. So you accept this. At the same time, you do the opposite for this one. You reject it, right? When you accept alternative means you reject null. When you reject null means you accept alternative, right? If you reject alternative, do you accept or reject null? When you reject alternative hypothesis, yes, you accept the null. When you reject alternate, you accept the null. When you reject the null, accept alternate. It's the other way. Very easy, straightforward. Okay, let's take a look at the first analysis that you will have to perform if you are going to collect data from the questionnaire. This is to test to see if multiple questions of Likert skill survey are reliable, whether your questionnaire set is reliable or not. And this is the guideline. If your Cronbach alpha fall under 0.7, if you have 0.7 and below, then your questionnaire question is questionable. Questionnaire question is questionable. This is compulsory if you are create new questionnaire by yourself. I repeat, this is compulsory if you are creating questionnaire or survey question by yourself. You need to do this to tell and prove that the questionnaire or the survey question that you have created is reliable. Reliable for analysis. What does it mean by not reliable? You do not have the chance to do the questionnaire for this semester because you all are going to come out with very funny questions. Though you are testing the same hypothesis, you are going to ask different kind of question. Say, for example, under the same alternative, family and economic correlate positively with academic performance. So let's say you're going to create your own questionnaire, right? What question are you going to ask people if you want to collect data? Family economic. What question you're going to ask? Okay. What is your parents' job, right? What else? Oh. Give me the full sentence. Family salary. What else? How many children? How many children do you have? Yes? How many children do you have? 我就开始笑了，这笑什么？Okay, what else? 不是不是，你讲不是不是 ，no no teacher no no okay no no okay okay what do you want to ask? How many children? And you are going to distribute the questionnaire to your friends, you know, all the degree students, because you want to find out whether their family economic correlate positively academic performance. You say, how many children? Question mark. You love, huh? You really do this, you know, family salary. Then people will be asking, family salary including my father, my mother, my elder brother who is working now. Does it include that? Oh. So you have to be very specific. What is your parents' salary, right? Do you think that they know this? They don't know. Then you have to improve. What is your parents' salary range? Do you think you know this? Range from, maybe range from the lowest 1K to 2K. I think you should know this, right? 2.1K to 3K. At least you know the range, right? And then why do you ask about parents' job? Does this actually tell you anything about the economy? If someone is a cleaner, does it mean that they have very low economy, no money? No. If, let's say, your parents is a part-timer, does it mean that they have lower salary than the full-timer? That's why the thing quit, because part-timer earn more than full-timer. Yeah, this is true to me lah, but I'm not sure about others lah. Okay, it doesn't tell anything from your parents' job here. Now, when it says someone like sell nasi lemak and a lecturer, does it mean the lecturer earn more than those sell nasi lemak? So what can you tell from here? Cannot. That's why when I look at this, I say, no, this one, no, this one, no. And then this one, no, like it the How many children are there in a family, in your family? Okay lah, this one can. How many children you have? Oh my God. You have all different sorts of questions. So every week, I really headache to check your seniors' question one by one. From just one hypothesis. Imagine they need to do 10 hypotheses. Each one, 2 objectives. You know, last time, each one, 2 objectives, 2 hypotheses. And each hypothesis, you have to come up with minimum 5 questions. So how many questions I have to check? Headache. And therefore, okay, if let's say I don't check this, then you tell us your Chromebase Alpha. You collect your data, you ask people how many children you have, and then you ask what is your parents' job. And you come back to here, you check most of the time, your set of data that you collected using your own survey question will be at questionable level or even poor, unacceptable level. Okay? Again, you don't have to do this because the set of questions that you are using now is actually from a group of experts from that organization. So we don't need this because we don't collect our own data. We don't construct our own questionnaire items. We reuse other people's work. All right, so clear, yeah? All right? Don't come and ask me, Dr. Ting, we do Chromebase Alpha in our report. Wow, I say you go ahead, I minus mark directly. Why do you use Chromebase Alpha? Why do you use Chromebase Alpha? I told you already. What is this used for? Okay, next, t-test. T-test is a type of inferential statistic used to determine if there is a significant difference between 2 groups. We have 2 groups here. We want to compare whether there is any difference or not. Okay, there are 3 types of t-test. 1 sample t-test, independent 2 sample t-test, and also paired sample t-test. They're a little bit confusing, yeah. Let's go through very slowly. Before we perform carry out a data analysis, there is something that you have to make sure, double check. If your data set does not fulfill this qualification, you cannot use this data analysis. Like for example, Chromebase Alpha, we use Chromebase Alpha with the assumption that we use this word assumption in the research to tell us that we assume that this is true. If you are using Chromebase Alpha means we assume that this questionnaire is created by you, and therefore we use Chromebase Alpha. So when do you use t-test? We assume that your data set fulfill all these requirements. Number one, you have continuous or ordinal scale. Continuous, still remember the measurement scale, the different level. Continuous means numbers. It can be 1, 1.5, 1.6, 1.7, continuous. Ordinal scale. Ordinal scale, you have this number 1, number 2, number 3, number 4, number 5. What is your ranking? Top 5, top 3, top 2, top 1 with order. Ordinal scale with order. Randomly selected observation means you randomly select the respondents. Data is normally distributed. Data is normally distributed means this. This one. This is normal distribution in which you have very low at the beginning, very low at the maximum, very low at the minimum, and the highest. Most of the respondent will fall under the average. This is called standard normal distribution. Abnormal distribution will be something like this. This is abnormal. For example, this green line, this is skewed to your left-hand side. Whereas, okay, the rest are okay. The rest are the normal distribution in which the highest point is in the middle. The highest point is in the middle. This is normal. Abnormal distribution is something like this. Okay, can you see this graph? It's either skewed to the left, positive skew to your left, or negatively skewed to your right. But this is okay. This is a very nice one. Okay, you can check this by using your SPS. I don't think they have this. Let me open it here. Let it lock first. Let's come back here. Okay, next you have large sample size. Now the minimum sample size requirement is 30, 30, in order to carry out the test. But the larger sample size that you have, the more accurate result that you can get. Minimum sample size that you need is 30 to run an analysis. Variances among the groups should be equal for independent two sample t-test. So we will look at this afterwards. But normally all this, okay, you will need to check all these requirements. If all these requirements fulfill, then only we carry out the t-test. But then in the exam or in the midterm test, we will not ask you to go and run the analysis to test whether this data set is normally distributed or not, or randomly selected or not. Okay, we will not ask you to do that. You just have to memorize that these are the assumptions in order for you to run the t-test. Let me share. Oh yeah, I can share. Because I have logged in here. So I should be able to see it if I'm sharing. Yeah. This is from my laptop, yeah. Can you please mute it? Yeah. Okay. You can go to Analyze, Descriptive Statistic Frequency, and choose any of this variable. Then in the chart, you can use the histogram. You can also show the normal curve on the histogram. Continue. Then you'll be able to see something like this. Okay, this is the curve. Can you see that? So if you compare to the abnormal skew, oh, sorry, I'm tapping. Sorry, no wonder it's not. No wonder it's not responding. Sorry. Okay, so if you are referring to this is positively skewed or I'm so sorry. This is positively skewed or negatively skewed. This is positively skewed or negatively skewed. Can you see the line here? So it's positively skewed or negatively skewed? Positively skewed or negatively skewed? I cannot see that. It's too small, is it? Yeah, it's positively skewed. Okay, so this variable, you cannot use it for the test, right? Then what's the point of? I can just, I can just use my method, But this one I cannot enlarge it, so you cannot see it clearly, right? Now don't know我的手问要摆哪里。Let me stop my sharing first. Hey, those online, are you still there? 139个人在睡觉了呀！你看，它只有一个 can. That's all. Okay, all of the 139 still here. Yes. 我是病到有一点好笑啊！Okay, I got you. You're still there eating, is it? 哎呀，好可怜啊！我刚吃饱来还好，不然的话就是要给你们。Okay, 来 next continue. Let's take a look at different t-tests here. Yeah, one sample, independent, and a pair t-test. Now, one sample t-test, let's say for example, we want to test the average screen size, which is 10 cm. Okay, average screen size 10 cm, and we have a hypothesis. Let's say, for example, the manufacturer produce in bulk, right? The mobile phone, and then they have this average screen size. They want to test whether your mean screen size of the sample differ from 10 cm. Meaning that I will take a bottle of product and then I test it, I measure, and then I want to see whether I suspect that you do not have a standard screen size for every product. I suspect that, so I want to carry out a research. So my alternate hypothesis is that mean screen size of your sample is differ from 10 cm. I want to prove this. If I successfully prove this, means my accusation is correct. My accusation is true, that your product is not standard. Okay? Your product is not standard. But I cannot just take one sample. I cannot just take one sample measure. See, this is 10.1 cm. So it's not saying, I cannot say that. Because there are certain defects. I will not say defects, but there are certain, you cannot always say that machine is 100% accurate, right? So we must prove it by using statistic. We take maybe 100 sample, come measure. And then we run t-test, one sample t-test. And the statistic will tell us that your mean screen size of your sample statistically significant, differ from 10 cm. You know what I mean? Statistically significant from this 100 sample. Okay, so after you run the one sample t-test, now this is how it looks like lah. The result from one sample t-test after you take perhaps 1,000 or 100 or 500 sample. Okay, and then you test it. Then after you run one sample t-test from SPSS, you are going to refer to this SIG again. The SIG means significant. Does it significantly different from 10 cm? Okay. If it is, you look at this result. Is it significant or not significant? Is it significant? Okay, not significant. Correct, because it is more than, it is higher than, larger than 0.05. Correct, very good. Okay. For independent tools, this is the one sample t-test, yeah? You take the one sample and then you compare with the average, one measurement average. You have this average. I want to compare my sample with this one measurement. One standard measurement. Okay, I compare this group of things with one average screen size measurement. Now let's move on to the second t-test, independent two sample t-test. The two sample t-test is used to compare means of two different samples. Now in this case, you have only one group of sample, right? Just one group only, yeah? But you compare with one measurement. This one now will have two groups of people. Let's say we have two groups of athletes, and one group is taking placebo, and the other group is taking caffeine. What is placebo? Is it a kind of diet? Oh, a fake what? Caffeine. Treatment no active. Oh, there's no active property, such as sugar pill. But then it tastes like that lah, is it? They have certain tests that taste like the caffeine. Oh, okay. I learned something new. Thank you. What is your name? Brandon. Nice to meet you, Brandon. 变到傻了. Okay, now the hypothesis is that the alternative hypothesis, we don't look at the null hypothesis, we look at the alternate hypothesis. Sports performance will be increased by taking caffeine. We want to compare these two groups, and we say that the group with caffeine performance will be better than those who do not take caffeine. So you compare these two groups, whether it's significant or not. So you're going to measure their sport performance. For group A, okay, run 100 meters, shoot, pew, boom, okay, then you record. Then group B, pew, pew, pong, okay, then you record. And then you compare their result. Compare whether these two groups actually give you difference. Someone said something, Sukyong. Sukyong, it's like you think you know sick, then you become no sick. Not like take medicine, then no sick. 哇，苏江，这个哲理很深奥一下，我还没有病好哦，不能够 interpret 你的东西，对不起。Next continue 有点晕了。Okay, let's continue. Now this is the result that you are going to see after you run the test. We're going to see the independent sample t-test. And then you are going to see your significant. Okay. This one. equal variances assume and equal variances not assume. Okay, you look at the SIG for the two-tail SIG. This is the t-test for equality of means. This one, respiratory exchange ratio is the variable that they measure. Actually, they measure how fast is your, what is it, the breath that you take, respiratory exchange ratio, how fast respiratory exchange ratio. I think so. Okay, so they measure this for two big groups, and then they compare whether there is any difference between this group, two groups, right? Then the result here shows the F should be larger than 1. SIG should be smaller than 0.05 for information. But this one is in ANOVA, yeah? We take a look at this SIG two-tail here. The SIG two-tail here, both the result shows not significant. And therefore, you can conclude that there is no difference between those who take caffeine and those who do not take caffeine. That's how you interpret the result. Okay, statistically not significant, so there is no difference. Can you tell me whether you should reject or accept alternate hypothesis? Should you accept or reject alternate hypothesis? Should you accept or reject? Those online. No. Okay, Jason, thank you very much. We should reject it. Then how about null hypothesis? How about null hypothesis? Yes, accept. You're still there. Okay. The last t-test is called PET sample t-test. Okay, PET sample t-test. So for example, you're going to change your tire with rubber X and with rubber Y. And your alternate hypothesis is that there is a difference between the means of tires before and after changing the rubber material. There is a difference between the means of tire before and after changing the rubber material. Okay, so you're going to test it with rubber X and also test it with rubber Y, both. Okay, this is actually referring to the same group of people, but then they are taking first they are taking rubber X, then you test the performance, and then after that they change with rubber Y and they test the performance. It's to compare two different tires, but then you are using them on the same set of car, same batch of car, just that they are using for the first round they use rubber X, second round they use rubber Y. So you do not have two big groups, but then you have the same group, but you apply the treatment, different treatment on it. Then you compare whether there is any difference on that. So this is also to compare, right? Compare difference. So that's why we use the test to compare. Okay, this is the result. This is how it looks like. The result after you have run the PET sample t-test, and you were also referring to this. Is this significant? This Y significantly different from X? Does rubber Y significantly different from X? Yes. And therefore, what should you do with your null hypothesis? Yes, reject null hypothesis and accept alternate hypothesis. Okay, now the next thing that we'll have to do, we just do a very quick revision on what we have done. We have looked at the first data transformation or data pre-processing. Then number two, we look at the first one to compare the difference. We look at we have covered the t-test. The t-test to compare the difference, and there are three differences, three different t-tests. But before you do that, if you create your own questionnaire, you need to conduct compare alpha. new questionnaire, you will need to use Chromebook Alpha. Then t-test will have one sample t-test, independent two sample t-test, and paired sample t-test. Okay, one sample t-test, independent two sample t-test, and paired sample t-test. One sample t-test, you take one group only, but you're going to compare them with one standard measurement. One standard measurement. You compare this group of sample with one standard measurement. Okay, then independent two sample t-test, you have two different group of people, two different group of samples. You give them different treatment, and then you compare their result. Paired sample t-test, you have only one group, but you give them treatment A, and then later on you give them treatment B. Then you compare treatment A and treatment B, which one is better. Okay? Any question before I move on? No question. I have question. In the midterm test, you will be given scenario, and then you choose which data analysis to perform, right? So I'm going to give you a scenario. Our research method lecture is conducted hybridly, right? In hybrid mode. Okay? And now the lecturer would like to find out whether those attend online learn better than those attend offline. So the lecturer is going to take the results and compare their results. Their midterm test result. Those who learn online versus those who learn offline. If those offline perform better than online, then I'll ask all those online to come back after the midterm test. Huh? Fair? Huh? Okay, good. Now, let's see. Which type of t-test should the lecturer run in data analysis? 1, 2, 3. Those online. 1, 2, 3. One sample t-test. 2. 3 for better comparison. 2. Okay, the correct answer is 2. Independent 2 sample t-test, because we have 2 different groups. For number 1 and number 3, number 3 means those online, you have to come back for another 6 weeks time, repeat the same lecture. So for 14 weeks, I need to conduct 28 weeks of lecture. Because you have to attend 14 weeks of online, you sit for midterm test, and then you come back for another 14 weeks of offline, and you sit for midterm test. If the school can pay me for 28 hours, I'll be more than happy to come back. Because 1 hour is 110. I earn a lot, huh? 2,000 plus, huh? 3,000, eh? Wow. Yes, I'm more than willing to conduct that. Research, just for research purpose. If you are going to use number 3, pair sample t-test. Not possible. You can carry the previous learning because you have learned in the online for the previous 14 weeks to the next 14 weeks. Yes, you're right. That is under the, what is that? Validity test. Validity, threat to validity. Threat to internal validity. That is another chapter. You are ahead of us, Brandon. So those who are here offline learn better than online because Brandon is ahead of you all. He has already gone to I don't know which Mars, which planet already. The one is chapter 9 or chapter 10, I don't know. Okay, let's I'm breathless already. Let's call it a day. I'm going to give you the attendance now. class rep, can you please mark the attendance now? Can you WhatsApp to me who is here and who is not here? P1476. Yes, I'm still having class. 924103. Where is my Okay, Jawi all here. Who attendance from RSW group 1? Jawi all present from RDS. Ryan group. Not RSF. All here. For RSD group 456 all present. 1, 2, 3, 4, 5. Jensen's group attendance absent is Prem and Vino. And then Thomas, RSW group 2, Lau Hong Sung, Nicholas, So Yu Teng, Wang Yi Chen, Yong Chen Pei. Absent. All present for RSD group 3, RSW group 3 all present. 1, 2, 3, 4, 5, 6, 7, 8. I have one more group to go. RT is missing.